Okay, so this is question 2C, question 6, for the sake of record. So when we define this, it becomes -5 less than x plus 1 over x minus 2, which is less than 5. So again, we have a situation where we have constants bounding the fraction, which has the variable in the denominator. So I need to solve it in two pieces. So I break it in two pieces. The first piece will be -5 less than x plus 1 over x minus 2. Now I'm not using or, I'm using and. X plus 1 less than x minus 2 less than 5. Okay, so I'm using and because at the end of it, we'll have to get the intersection of the two intervals because we want where it is greater than -5, less than 5. So for the first piece, again, we take everything to the left and have this less than 0, so that we have x minus 2 as a common denominator because here we have 1. So we have -5 x minus 2 minus x minus 1. So I've expanded here. I hope you're able to see that. Then we'll have -5x plus 10 minus x. And I think I solved this question yesterday. X minus 2. Anyway, it's a good revision. So that we get -9. Okay, sorry. So we get -6x plus 9 over x minus 2 less than 0. So this will take us to a table because now we get the critical values. So we'll have x is equal to 2 and x is equal to 3 over 2. So we got the table. We'll have -6x plus 9. We'll also have x minus 2, and we'll have the quotient here. And then, so we break into pieces here. So I'm breaking like that, so that I bring these numbers. So here we have 3 over 2, and here we have 2. And then we pick a number in between. Now the best way to pick a number in between is to add. So I have 3 over 2 plus 2. So I'm going to get 7 over 2. Then you multiply this by half so that you get 7 over 4. In other words, you divide 7 over 2 by 2. So the middle number here is going to be 7 over 4. The number after 2 can get 3, and then here you can get 0. And then you start testing. So the first one, when we substitute in -6x plus 9, we substitute where there's x here, we bring 0. We have 0 plus 9, which is 9. The interest is in the sign. 9 is positive, so we go with a positive here. When we take to x minus 2, you substitute 0, you get -2. The interest is in the sign because someone else could have used even -10. It's still a number that is less than 3 over 2. So we get the sign, then you multiply these, and then you get the negative sign. You got the middle one, so I know that here I'll get plus, and here I'll get minus. So as I'm going there, I'm just going there to make sure that I got the correct thing. That is -6, 7 over 4, plus 9. So here we'll get negative 3 by 7 over 2 plus 9, which is negative 21 over 2 plus 9. So this number is bigger than, this number here is bigger than 9. So the negative of it, when I add 9, I'll have a negative now. And then again, we have 7 over 4 minus 2. This is 7 minus 8 over 4, which is negative 1 over 4. I'm interested in the sign. When I multiply, I'll get a positive. 3, this will be negative, this will be positive. And what are we looking for? We're looking for this, where it is less than 0. So where it's less than 0 is our solution. So I'm saying for this one, the solution set is this piece and that piece. So this is negative infinite all the way up to 3 over 2, not including any boundary, 2 up to positive infinity. This is not the final answer. This is just the answer for this piece. Then we got the remaining piece, this one, and solve. So when we solve that, again, same approach, x plus 1 over x minus 2 minus 5 is less than 0. So we have x minus 2, and then we have x plus 1 minus 5 plus 10 less than. So this 5 is 5x less than 0, so that we get negative 4x plus 11, x minus 2 is less than 0. So again, critical values, the other one is fixed, 2, the denominator, and then the other one is going to be x is equal to 11 over 4. So again, we have 2, we have 11 over 4, and then we have negative 4x plus 11, we have x minus 2, and we have the quotient. So same procedure, we pick numbers 1 less than 2 and the other number in between. So number less than 2, I'll pick 0. In between, again, we add 2 plus 11 over 4, then divided by 2. That will be 19 over 4, divided by 2 to be 19 over 8. So we have 19 over 8. After 11 over 4, you get, you can get a number, even 5. So now, this was negative 4. Okay, let me put it well. Negative 4x plus 11. Okay. So when we substitute 0, we'll get positive. So we substitute 0, we have a plus. We substitute 0, we have a negative. The product, negative. Meaning that here I'll get positive and I'll get negative. So you can finish up the table. And then the solution set for this piece is going to be, where it is less than 0 again, negative infinity all the way up to 2, union, 11 over 4 all the way up to positive infinity. Then now our solution, the final answer now, the solution set is equal to the intersection of these two. So we have negative infinity, 3 over 2, this intersection negative infinity 2 union 11 over 4, infinity. So the intersection here, you must be familiar on how you get intersection of intervals. So for the left side, I'm getting negative infinity. I'm also getting 3 over 2. Then union. For the right side, I'm picking 11 over 4. And we have infinity here. So this is our solution set. Do we have any question? Anyone with a question? So if you have a question, you unmute and ask. So that if there's no question, I move on. Okay. That's a good go ahead. The next question now. Now that there are no questions and we started this question yesterday, it will be okay for us to move to question. Because D is the same form, D is the same as B. So I can solve E, which is x plus 6 less than x minus 2. And there are so many ways of solving this. So because I've been using tables, here now I want to change the method. So I'm going to use the square root definition of this. So I haven't changed anything. I've just redefined this because I know that this is the same as this. So if we have this and we square them, we're going to get x plus 6 squared less than x minus 2 squared. And this is going to give us x squared plus 12x plus 36, which is less than x squared minus 4x plus 4. So that when we put the x squares together, this and that will cancel. And then I'm going to have 12x plus 4x less than 4 minus 36. So that we get 16x less than negative 32. We divide by 16, divide by 16. So x is going to be less than negative 2. So it must be making sense. So if that is the case, can we try 4? Can we try 0, the easiest, and see if our interval here is wrong? So I'll try 0 plus 6 must be less than 0 minus 2. This will be 6 less than 2, which is not true. So the interval is telling us something which is right, because it's saying that the only values of x that satisfy that inequality are the values which are less than negative 2. So that the solution set becomes x a real number such that x is less than negative 2. So I can write my answer in this form. I can write my answer in this form. There's nothing wrong. So that you guys are going to do question F as well as question D. So that our job today is to do question 3. So we go to question 3. So we go to question 3. A, 10 minus the square root of 2x plus 7 less or equal to 3. Solve the inequality. So here again, the interest is just to find the values of x. So you can take the constant the other side so that we have 2x plus 7 is less or equal to 3 minus 10. This is just negative 2x plus 7, which is less or equal to negative 7. We can divide by negative 1 so that we get the square root of 2x plus 7 is greater or equal to 7. Now I've done this derivative so that for those who want to square just here, you have this less or equal to negative 7. If you decide to square here, your next answer must have this inequality changed because you have multiplied by negative. So you keep that in mind so that when we square here now and on the right, we're going to have 2x plus 7 is greater or equal to 49, which must have been the case here. When you square, you get 2x plus 7 greater or equal to 49 because you've tampered with the sign. So that we take 7 the other side and have 2x greater or equal to 42. We can divide by 2, so x will be greater or equal to 21. Of course, you know what you're looking for. So you can try to go and check if this is true. Is it true? You pick the same 21 and see what it's going to give you. 10 minus 2 by 21 plus 7. What are we getting? We have 10 minus 49, which is 10 minus 7. This is 3. So it's fine. Now, if we increase, since x must be greater or equal to 21, if we get a different number, say we get 25, we have 10 minus 2, 25 plus 7 inside. This is going to be 10 minus 57. Okay, but we know that the square root of 57 is greater than the square root of 49. So it must be, because what will come out here will be greater than 7. So when you subtract that thing from 10, what should remain will be less than 3. So the solution set is making sense. And so you write your answer. You say, okay, so the solution set here is x such that x is greater or equal to 21, but my x is a real number. So I have seen 3 representations of your solution. The other one is here. You can also write it like this or like this. So you can present your answer in any of these forms and your answer will be correct. Now you can ask questions. Don't be this quiet.
Sir, I have a question.
Please ask.
Why didn't we try to find the radicand in this situation?
Why didn't we try to find the what?
The radicand. The radicand, they usually equate the part under the root equal to 0. Why didn't we do that? Or maybe it's irrelevant.
You only do that when you want to. We do that mostly when you want to sketch. In this
Okay.
case, our interest is to get the values of x.
Okay, thank you, sir.
So if I give you a question like this, if I say sketch f of x is equal to 2x plus 7. Your first thing, even if I add the 3, your first thing is to get the radicand. You do this and get this, so that when you sketch it, you know that you are starting from this. Because when you substitute this number in here, you get a 0, and so you have a 3 responding, so that your starting point is that one. And then you follow the formula of your graph, so it should go that way, guided by the starting point. That's the only time we are asked to determine the radicand and then move on to other properties. Any other questions? So we don't have any other questions, so we can move on. So can I do B? Okay. Let me do B. 3 less or equal to 2x plus 5 less than 6. So again, this one is direct. I square, I square, I square. And I'll get 9 less or equal to 2x plus 5 less than 36. Then take this number there, take this number here. So I have 9 minus 5, 2x, 36 minus 5. 4, 2x, 81. Bracket 2x. Done. So that's less complicated anyway. So this, you follow the same approach. C is almost the same as what you're doing here because you're just squaring these guys. You know, they're like this. 2x plus 9 minus 9 plus x greater than 0. So you say 2x plus 9 greater than 9 plus x. You square 2x plus 9 greater than 9 plus x, so that you get x greater than 0. That would be a solution. So my assumption is that since we have no questions, my assumption is that we can be able to finish this question that have remained. We've just made with D and E. So you must be able to finish because you keep on squaring until there's no more square root and you have the values of x that you want. Is that fine? So D and E. So we can now log out and log back. We still have time. We have to go up to 15 hours. So let's log out and log back. We start to Rashid 10.